Hello guys, this video going to talk about the revision exercise 1 about your first term exam. So for the first questions, we're going to simplify the following expressions, and the main thing is to express the answer with positive indices. So if you have something like a to the power of negative 6, you have to change it back to 1 over a to the power of 6. So I don't want to, any indices is not negative numbers. So lots of students did this mistake. So please make sure that you didn't make it next time. Okay, so for the first questions, we have b to the power of 5 times 3b squared. So first of all, we can separate it into b to the power of 5 times 3 times b squared, isn't it? So we move the 3 to the front, then we have b to the power of 5 times b squared. Then we can use our formula, a to the power of a and a to the power of n times a to the power of n is actually equal to a to the power of n plus n. So that's the formula you should remember. And then we have 3 times b to the power of 5 plus 2. So this is equal to 3b to the power of 7. Okay, so for the second one, we have 3x to the power of negative 2 times 4x to the power of 5. So first of all, we can write it with the times symbol. So 3 times x to the power of negative 2 times 4 times x to the power of 5. Then we can combine the numbers, 3 times 4, and then we combine the x, so x to the power of negative 2 times x to the power of 5. So 3 times 4 gives you 12, and then x to the power of 2 times x to the power of 5 is basically just negative 2 plus the 5. We use this formula again. So that we can say this is equal to 12x to the power of 3. So for next questions, we should use our equation that's the ab to the power of n. The power of n can be distributed to the things inside the bracket. So we have a to the power of n times b to the power of n. So which means that we can first of all distribute this power 3 to both of the 5, the b's and the c's. Okay, so which means we can write it to 5 to the power of 3 times b to the power of negative 3 to the power of 3 times c to the power of 7 to the power of 3. So then we can use another formula, which is a to the power of n bracket to the power of n is equal to a to the power of n times n. Okay, so now 5 to the power of 3 is equal to 125 by using a calculator. Then the second part, we have b to the power of negative 3 times c to the power of 7 times 3. So then we have this is equal to 125 times b to the power of negative 9 times c to the power of 21. So then we can use our formula that b to the power of negative n is equal to 1 over b to the power of n. So when they have a negative power, we just switch the sign, becomes 1 over, and then we can have the positive indices. So then this is equal to 125 c to the power of 21, and it's divided by b to the power of 9. Okay, so for part D, we need to understand that for anything to the power of 0, when it's, the anything is not equal to 0, then it's actually equal to 1. Okay, so for this part, is this the anything to the power of 0, so the whole thing is actually equal to 1, but we still have the front. We have 4 times a to the power of negative 6 times 1. Here we have a negative power, so we use this formula to change the thing to the denominator to get 4 over a to the power of 6. Okay, so for part E, we can use our formula that ab to the power of n is actually equal to a to the power of n times b to the power of n. So we can distribute this negative 3 to both of the 2 and n cubed, which means that we have 2 to the power of negative 3 times n to the power of 3, all the thing to the power of negative 3 again. And then for the denominator, it's the similar thing. Negative 2 is our power, so we distribute it to the 4 together with the n. So we have 4 to the power of negative 2 times n to the power of negative 2 as well. Then, because there's all of those are the negative powers, so to switch them, we can have this 2 negative stuffs back to the front, back to the numerator. So we have 4 squared times n squared divided by 2 cubed times n cubed to the power of 3. Okay, so what we just done is just actually swapped the denominator and the numerator. You see, from the denominator to the numerator, and the negative power change to positive. So for this part, the negative 2 power change to the numerator becomes the positive. So for this numerator, negative 3 is changed to the denominator. Similar for this one is changed to the denominator. So then we can simplify this. 4 squared give you 16. 16n squared divided by 2 cubed give you 8. And then n to the power of 9. Because we can using our formula that the a to the power of m to the power of n is equal to a to the power of n times n. So now we can simplify further. Then we can using our formula a to the power of n divided by a to the power of n is equal to a to the power of n minus n. So which means that the 16 divided by 8, we have a 2 left. And then because the n squared is actually smaller than the n to the power of 9, then we can divide it by using n to the power of 9 minus 2. So we have 2 over n to the power of 7. Okay, so for last part, we have the negative 2 as the power. So we can again using our formula, ab over c to the power of n is equal to a to the power of n, b to the power of n divided by c to the power of n. And we can say this is equal to 3 to the power of negative 2 times b to the power of negative 2, all the thing to the power of negative 2. We're just distributing this negative 2 to all of the things inside the bracket. Then we need to divide by a to the power of 3 to the power of negative 2. Okay, so for this part, you can see that b to the power of negative 2, all the thing to the power of negative 2 means that these two numbers can be times together to get a b to the power of 4. Then how about this 9 to the power of negative 2? You can switch to the denominator to get 3 squared. And then for this part, we got a to the power of 3 times negative 2. So 3 times negative 2 actually gives you negative 6. So now we still have a negative power, so we switch back to the numerator. Then we have a to the power of 6, b to the power of 4 divided by 9 squared, 3 squared giving you 9. Alright, so that's for part A, part 1. And then now we're going to do the question 2. We want to change the following into the integer or decimal numbers. So first of all, if you times 10 to the power of 5, which means that we want to make this original number become larger. Okay, so what you're going to do is copy down the original number and adding some zeros on the right. If this power is positive, then you're adding the 0 on the right. If this power is negative, you're adding the 0 on the left. Okay, so now the dot is here. It's going to times 10 to the power of 5, which means I want to move the dot to the right hand side by 5 units. So 10 to the power of 5 means that I move the dot to right for 5 units. Okay, so 1, 2, 3, 4, 5. So now we copy this down is equal to 801,300 dot. Okay, so now this number should be equal to 801,300. Okay, so now for the second one, we have negative 1208. So we're adding some zeros. And where is the dot now? The dot is actually here, is after the 8, because this is an integer, so the dot is just near by the integer digits. So now we're going to have the 10 to the power of negative 4, means that move the dot to left for how many units? For 4 units. Okay, so now we move it. The dot is here, 1, 2, 3, and 4. So the dot is actually moving to the left part. So now we have negative 0.1208. That's for question B. And now we try to do question 3. So this is bigger than 0. So we're adding some zeros on the right. Okay, so now we want to move 3 times to the right. So 1, 2, and 3. So the dot is moving to here now. And then this is actually equal to 25400. Okay, so for the next part, we have negative power, so which means I'm adding some zeros on the left. So now the dot is originally here to the power of negative 3, so move to 3 units, 1, 2, and 3. Just do it slowly, make sure that you moving the dots unit by unit. So we have the dot is actually here, 0.00627. So that's for question D. Okay, so now we want to change numbers into scientific notations. So scientific notation means that we want a number write it in a times 10 to the power of n, where a is in between of 1 and 10. So it's not equal to 10, it's actually greater than or equal to 1, but it's actually smaller than 10. So what we want is 1 smaller than or equal to A is smaller than 10. Okay, so what's the constraint? What's the condition for the m? So m should be an integer, no matter it's positive or negative. Okay, if that is a positive, which means that it's a large number. If that's a negative, which means that it's a decimal. Okay, so now we have this number is very large, okay? And then first of all, into finding out what is the significant figures. It's actually 3 and 7, but we can't write it as 37 because we want our a's in between of 1 and 10. So what we can do is just put the dot here. So which means that is equal to 3.7 times 10 to the power of something. Then how can we decide this power? The dot is originally here. We want to move it to the left. So it's 1, 2, 3, 4, 5, 6, and 7. Okay, so as this number is much more smaller than this, so we want to make it bigger, so it's actually 10 to the power of 7. So as again, this dot should be moving from 1, 2, 3, 4, 5, 6, and 7. It's moving for 7 units, so the power will be 7. So for the second one, we have negative 412,000. The dot is originally here, and where we want to put the dot is here. So this is equal to negative 4.12. How many digits is going to count? So 1, 2, 3, 4, 5. So it's going right for 5 units. So you need to times 10 to the power of 5. Okay, so for this one, a lot of 0 at the front of the numbers. So the significance figure is actually these 3 figures. And what we want is the A should be in between of the 1 and the 10. So we should choose this 3.12. And then how many dots we should be moving? So 1, 2, 3, 4, 5. So then we can write it as 3.12 because we are making the numbers be smaller. So we want 3.12 times 10 to the power of negative 5. Once again, if you want to make the number be larger, you see this is a large number, then we need to have a positive integer. If you want a smaller number, then we need to make the indices be smaller, be a negative number. So for the last one, we have negative 0.000103. So first of all, our dot should be putting here, isn't it? So now we have negative 1.03 times 10 to the power of what? So you can see like this is moving from 1, 2, 3, 4 times. But actually, we're making this number be much more smaller, so we have to take a negative 4 as the power. Okay, so that's for question 3. Alright, so now we can try to do the question 4. So for question 4, please bear in mind that the answer should be in scientific notation as well. So first of all, we can take out a common factor, which is equal to 10 to the power of 6. And then what we left after you giving the bracket, after taking out a common factor and to give me a bracket. So what we left here, we take out a 10 to the power of 6, so what we left is just 5.4. So 5.4 minus 8.2 times 10 to the power of 6, so this point is eliminated. So what we left just 8.2. So we try again, 8.2 times 5.2, 5.4 minus 5.4 is actually equal to 2.8. So it's actually equal to 2.8 times 10 to the power of 6. So now we're going to try question 2. These two numbers are not the same, so we're trying to take out the largest possible indices. So it's going to be 10 to the power of 5, taking out, then we have 3.7 times 4.6, so it should be plus 4.6 times 10 to the power of negative 1, isn't it? Because from this part, 5 times 10 to the power of negative 1, so that can give you 10 to the power of 4. So now we can simplify this, becomes 10 to the power of 5, 3.7 plus, this is times 10 to the power of negative 1. So which means that this number should be moved to the left-hand side by 1 unit, which means that it's going to be plus 0.46. Then we can say that the answer should be equal to 4.16 times 10 to the power of 5. Okay, so for the next question, you can see from here, we got the common factor 10 to the power of negative 4. So we take that out, 10 to the power of negative 4, then we're adding a bracket. So we have 4.23 minus 3.17. Then we do the calculation, then we can have this is equal to 1.16 times 10 to the power of negative 4, which is correct. So for the last part, we want to take out the largest common multiple, which is 10 to the power of 5. So if you take out 10 to the power of 5, which is going to be equal to 1.78 times 10 to the power of negative 7. So once again, because this is negative 5 times the power of negative 1, which means that negative 5 should be minus the 1. Okay, then we minus the 3.4. We take out the 10 to the power of 5 already, so there's nothing left. So this is equal to 10 to the power of 5 times 0.178 minus 3.4. So I think this is better to switch them, so it becomes negative 10 to the power of 5 times 3.14 times 0.78. So the answer should be equal to minus 10 to the power of 5 times 3.1 minus 0.18. So 3.14 times 0.178. So this is 0. You got 2 left. Then 13 minus 7 gives you 6. And then what we have is 3.4. Sorry, 3.14. So this should be 0. Then they have a 9. So it's 2.962. So try to use the calculator to check it again. We have 3.14 minus 0.178. This is equal to 2.962, which is correct. So now we have the answer should be equal to negative 2.962 times 10 to the power of 5. Sorry, negative 5. We take out the negative 5, isn't it? Okay. So that's for question 4. So now we're trying to do the question 5. We need to factorize the expressions. So first of all, the 20 can be actually written as 2 times 10 times A times B plus 10AC, isn't it? So now we're trying to find out what is the common factor. We have 10, we have 10, we have A, we have A. So we take out a common factor. We have to take out the 10A, then you're adding a bracket. So what we left is 2B plus C. So that's for question A. Then for question B, you can see that the common factor is A plus 1, isn't it? A plus 1. We have the common factor, so we take it out first. We have the A plus 1 as the common factor. After you take out the common factor, you give me the bracket. So 9 times A plus 1, you take out 9 plus 1, so what we left is just 9. So we write down the 9, we keep the sign plus. So for the second part, we take out A plus 1, so what we left just the B. So it's 9 plus B. Okay, so don't expand the bracket. If you expand the bracket, you actually can't see the pattern. Okay, so before you do the factorization, you try to find out what is the similar stuffs. Okay, so for the second part, there's 4 things, but there's no one common factor among all of the terms. So we try to group them together. We group the first 2 and the last 2. So for the first 2, what we have as a common factor is actually the A. And then for the second group, the common factor is going to be 2. So we can take out the A, and then 7AB take out A, we have 7B. And then AC take out by A, we only have C left. Keep the plus, and then what we have here, 14 and 2, we can take out 2 as the common factor. Then what we left is 7B plus C. So once again, there's another common factor, 7B plus C, isn't it? So it is equal to 7B plus C times what we left is just A plus 2. A plus 2. Okay, so that's for question C. So now we can try to do question B as well. So again, there's no common factor among all of the 4 things. So into adding a bracket. So adding the first bracket, there's no problem, but when you're adding the second bracket in front or after the negative sign, okay? When you're adding a bracket after the negative sign, we have to change the sign in the middle, okay? So if you're adding the bracket here, we need to change the sign to be negative, okay? So we have bx squared minus bxy. So for the first bracket, we have ay as the common factor. So we take out the ay, then what we left is just x minus y. And then for the second part, we can take out bx as the common factor. So take out bx and we have x minus y as the remaining thing as well. So then we can find out x minus y is the common factor. So we take that out, x minus y times ay minus bx. Okay, so for part E, it's x squared minus 7x plus 6. So it's actually a similar type of our quadratic formula. Okay, using the formula 0, 1, they're asking about ax squared plus bx plus c, then we can just using the formula 0, 1 to solve it. So after we press formula 0, 1, the a here is the number in front of the x squared. You can see from here x squared is equal to actually 1 times x squared. So first of all, you need to write it down. A is equal to 1. Then b is actually equal to negative 7. B is equal to negative 7. So c is actually equal to 6. If you put all of the numbers into the calculator, then you can see that we have an x equal to 6, isn't it? So x equal to 6 can be written as x minus 6. So now we have the first factor is equal to x minus 6, and the second factor is x equal to 1. So second factor x equal to 1, which means that x minus 1 is the second factor. Okay, so now we're trying to do question F. Like, this is very similar, but if you just put it in the things inside, it's going to be wrong. If we have a negative, we first of all take out the negative first. So if you don't take out the negative, you're just using the calculator directly, you will get the wrong answer. So take out a negative, which means that we change all of the signs inside the bracket. So we have y squared with minus 7y with now minus 8y. Then we can use our formula 0, 1, 1, negative 7, negative 18. So we can say this is equal to negative of y minus 9 times y plus 2. Okay, so that's for question F. And for question G, there's something special. There's a number in front of the x squared, but we can still using our formula. What is our A? A is 7, B is negative 25, C is 18. So C is 18, which means that in the calculator shows that we have x is equal to 18 over 7. So we try to move all of the things to the right hand side, to the left hand side. So we have times to 7 first. So 7 is equal to 18, so that we have 7 minus 18 equal to 0. Or we're doing to write down the 0. So 7x plus 8 is the first factor. We just write it down. 7x plus 8 is the first factor. So for the second factor, it's going to be x equal to 1. So x equal to 1 just means that x minus 1 is a factor. Okay, so for the last part, this 3 is not in front of x squared, so it's not the coefficient of x squared. So instead, it's negative 5 is the leading factors. So we can say that the negative 5x minus 14x plus 3. So as again, we need to take out negative first. So negative times 5x squared plus 14x minus 3. So then this is actually equal to, you put a as 5, 14, negative 3. So then you can get the negative of 5x minus 1, and then we have x plus 3.